Okay, it's time to start. Thanks for coming. I'm Levent Gurgen from CA, which is a research institution in France. 16,000 people, so it's a large research institution. So today I will be talking to you about our open platform for smart cities. It's a new Eclipse project, so we have just joined the Eclipse Foundation about 6 months ago. So I hope to be able to give you some details, not so much technical details, but overall presentation of the platform, as well as some deployment examples that we have done in several cities in Europe and Japan in particular. And finally, I will be talking about an initiative that we are launching among our different members, which is called Urban Technology Alliance. Just let me give you some facts and figures about why the cities now should be more smarter. Currently, more than half of the world population lives in cities, and it will increase in the coming year for sure. And this has direct impact to urban citizens and cities in managing different resources that they have: infrastructural resources, environmental resources, economic resources, etc. Just to give you an example, huge water leakages due to the bad management of the pipes, let's say. The energy consumption, Europe is currently importing the 50% of energy consumption, and this is expected to reach 70% by 2030. So some measures have been taken by the European Commission in terms of more efficient usage of energy. Transportations also in huge environmental and economic impact due to also inefficient management of the transportation systems, parking spaces, etc. So in order to make this smart, so what we need is indeed that they should be aware of what's going on. For this they need sensors, and the sensors can be physical devices, but also other data sources that can provide necessary information to have this awareness of the city environment, such as social networks, also huge source for data, legacy devices, mobile applications, and for sure IoT devices that they are now quite small, wirelessly communicating capabilities, embedded storage, computing capabilities, etc. And then we have to indeed collect this data, analyze it, and extract some high-level knowledge from them, and make plans and make actions that have some desirable effects on the environment, which is also challenging. So just to take decisions, planning and actions not sufficient, but we also need to have these desirable effects. And finally, all is for providing some citizen-centric services from different domains: transportation, building, security, smart retail, etc. For sure, there are several technical challenges to be managed. Heterogeneity is one of them. So it is a reality today that we have a huge number of, let's say, standards, protocols, different device manufacturers coming with their specific APIs, data models, etc. So this is the current situation. So we have to live with that. We are talking about billions of devices, a huge number of data to be managed. So we have to also handle this. The physical environments are dynamic, so we have to be also tackling with this dynamicity. The systems, they should be working in a plug-and-play fashion. They should be able to self-configure, self-adaptive to the changes in the environment. Also, what we do, we need indeed to make rapid prototyping, but those prototypes should behave as we expect how they have to behave. So the applications should be dependable, and yes, without no doubt, security and privacy are also important non-functional requirements that we have in this domain. So what we have is indeed this sensiNact platform, which we deal with in particular the heterogeneity. So we have possibility of hiding this heterogeneity behind our platform. So we are providing access in a homogeneous way to this data, heterogeneous data, and provide some APIs that allow to the developers to access to that data in real time It can be on demand, periodically, or event-based, as well as access to the historic data for offline analysis, for example. And on the northbound side, so to access to all of this data, the developers can use their favorite protocols. It can be REST APIs, it can be some standards to be able to access to that data in a homogeneous way. We also provide a tool that allows managing those devices, as well as creating rapidly some rule-based applications that the developers can build and deploy to the platform, and they can manage their life cycle. So this is the kind of the overall architecture in which we have indeed the core part that provides some facilities to build rapidly some bridges for different communication protocols and specific to device manufacturer, APIs or data models. So we are providing this in a modular fashion. So tomorrow, if you want to add a new support for a new protocol, it's quite straightforward and easy to add this new support to the existing running system, even in runtime. And as I mentioned, on the northbound side, we have also this modular way to add new support for accessing those data. We have also some plugins that we can use as extension points in order to allow some new operations to be performed in the collected data. So someone specific wants to make some specific analysis on the data so that they can integrate to the platform this processing function to the environment. So we have a service-oriented approach in which we have all these communicating nodes exposing their functionalities in terms of services. Typically, such sensor node would be attached by different sensor devices, and each of them provide services like detection of the wind level, temperature, some GPRS modules that can allow you to make calls or SMS, etc. And then these are accessed in a resource-oriented fashion, in which actually we have, as I mentioned, this service provider service and resource approach, in which we have this 4 types of resources. So we can do, we have resources such as properties of devices, for example, sensor data that they can provide, actions that we can do on the actuators, for instance, and those actions which modify some state variables of the devices. So all of these 4 types of resources can be accessed by these generic access methods. Typically, we can get at any time the sensor data value or property value or state variable value. We can modify the property values to configure some specific parameters. It can be security parameters or localization information, etc. We can do these actions on the actuators, and we can in particular subscribe to any of these in order to get notified when there's any change at those resources. As I mentioned, we are providing high-level APIs to allow the developers to access to that data, as well as creating their applications and deploying them in the platform by, in particular, using this sensiNact Studio tool that allows rapidly creating those applications. So this studio looks like this. So at left we have all the available devices, the services, resources that they expose. We can visualize them. We can create some graphs by subscribing to the events. And we have this DSL editor in which we can rapidly create some rule-based applications. It looks like this. For example, we are using Xtext to create this grammar of this language. Typically, this says when you detect someone, you turn on a light or you turn off the light, the first one. And then we can make the things a bit more complex, in which we say if 2 presence detectors detects someone in a sliding window of time of 3 seconds. At that time, we decide that there is someone there, and only at that time we make the necessary action. So we can do things a bit more complicated. So this was a very quick presentation of the platform. So we have just joined, as I mentioned, to the Eclipse Foundation, so you can find some more information on that. You can, in particular, access to various city real-time, real-life data available on the platform currently. I will present it later, but we have already established different projects in which we are now working with the cities, and we can collect various data from those cities, particularly from Europe and Japan. So typically in Santander, for example, we have thousands of devices already deployed in the city, so we can access all of the city, the parking space, sensors, some bike sharing stations, or temperature sensors, the pollution sensors, for example, that are deployed on the bus, public bus of the city. So all of this information we can gather. Also from Japan, we have similar deployments, and we can access in real time all of this data. So yes, we are indeed looking for contributions to enhance the platform, to add new features. So as I mentioned, we have this website in the Eclipse, hosted by the Eclipse Foundation. We have documentation there, which is continuously being updated for sure. And we have also the Swagger, that if you would like to get data by using the Swagger, you can access to those real-time data and in real-life data by using those APIs. So indeed, we have established this base of data by using our platform in different collaborative projects from the smart city domain, for instance. So I'm coordinator of the Big Cloudy project. This is an EU-Japan project, which is a follow-up of its preceding one, in which we have worked with different cities, in addition to another European project, Organicity, that allows us access to data from London and ours in particular. I will give you some specific examples on that. We are also currently doing a deployment of a LoRa gateway in a ski station in Grenoble area, Champs, in which we will be collecting data coming from skiers with sensors attached to their ski shoes that measures how they ski, in which speed, how they take the curbs, and how much time they stay on the air. So this kind of parameters we collect, and we then provide this as kind of recommendation for the skiers to improve their skills. And also we provide this data to with the consent of the skiers, for sure, to the ski resort operators, in order to allow them to better see in which area is more crowded and how to better manage the assets that they have in the station, as well as also monitoring, for example, in terms of emergency. These sensors has also some buttons that trigger some alarms to handle the emergency situations. So this is a joint project also with Korea. So the Winter Olympic Games will take place in Pyeongchang in February 2018. So we will be making some simultaneous deployment with them. We have some other EU-Japan project in which we have deployed some sensors in 3 train stations in Japan. We are also have an ongoing project on the farming domain, in which we are working with the wine domain. We are deploying also LoRa network there, and with some sensors to gather real-time data from the soil temperature, humidity, as well as some more information about the farm, about the wine domain. And then the domain is using this information to better manage the watering the domain, or taking some specific measures on those. We have also some smart home related deployments. We are managing with our platform different heterogeneous protocols coming from Europe and coming from Japan as well. And finally, we have also a recent project in which we will be deploying our platform within about 100 houses in Grenoble area, in order to provide more autonomy to elderly people and to help them to make their life more comfortable, more secure, by monitoring their daily activities, triggering some alarms, etc. So a specific example indeed within this EU-Japan project, as I mentioned, we have access to this large infrastructure from Santander City with thousands of devices already deployed, parking sensors, traffic sensors, some pollution sensors deployed on the buses, sensors deployed in the public gardens, etc. Similarly, in Genova City, we have these environmental sensors, some webcams, city information displays. All of this information we can access. Similarly, as I mentioned, in Japan as well, we have this pollution sensors deployed on the garbage trucks that makes the every day the same road, so that we can have a comparison between day to day about the pollution levels, pollen levels in the city, and provide this information to the city staff as well as to the citizens. So we have deployed several trials in these different cities with about different domains. So what we did in this project in particular, we used sensiNact to gather all of this heterogeneous data, and we provide then this data for different purposes. A tool, service development tool, as I mentioned, our sensiNact Studio that allows rapidly creating applications. Another data mashup tool from another partner. We have created some city dashboards. We have even created a kind of intercontinental competition to compare different parameters collected from different cities. So from this project that I had also the chance of coordinating, we have now went to the Big Cloud Sea project, in which we are adding big data aspect to the project. So some big data analysis, complex event processing that we are adding to this platform, in which we have also added new cities part of the project, like Tsukuba, Grenoble, and Bristol City. So not only sensor data, but also the data provided by humans is also important. For example, this Mina Repo crowd sensing case, in which the city staff actually they can use their mobile phones to inform some events to this, and they can feed this database, as well as the citizens. They have this Lokemon application, which is quite similar to Pokemon Go, in which they interact with some avatars in the city in order to ask to these avatars some information, like is there a long queue in front of this restaurant, or is there any interesting event to do today, etc. So this kind of interaction, it can be done via these different characters. We are also monitoring several IoT devices from Grenoble and air quality sensors from Bristol. So then we have this festival project, in which we are aiming at providing necessary resources to experimenters. So the experimenters can be researchers, they can be SME startups that they do not have this physical test beds to validate their applications, because they have these nice algorithms, nice ideas, but they need data in particular to validate their algorithms. And then so we provide this data, open data or IoT data. We are also providing some IT resources, computing power, storage power, etc., so that they can access to these experimentation facilities from different domains, city domain, smart home domain, energy management domain, etc. So this is an open platform in which you can access, and you can start to get data that we have there by using this platform. As I mentioned, we have some specific domains we are targeting, in particular energy, smart building, and smart shopping domain. Just to give you some examples, the smart station example, I have already talked about that. So we have several sensors deployed in those stations. One of the objectives is also provide within this displays some real-time information to the citizens, and also as a stakeholder, we have some advertisement company that would like to exploit this data and provide some context-aware advertisement on the digital signages deployed in this station. Smart energy management experiments that allows, in order to understand the behavior of the data centers, energy consumption, how they use for the data, for the cooling system, etc. We have also done some experiments in terms of person tracking with some privacy-friendly cameras, in which we don't transfer images, but we do some local processing on the cameras. From smart home domain, we have an interesting scenario in which we have involved an artist that also exploits the data that we provide. He's a video maker that uses these images from this camera plus some environmental data that he brings together and provides some silhouettes and nice effects. And he's making a video feedback between EU and Japan, so that the people from Japan, they see some silhouettes from Europe and vice versa. And there will be a specific presentation of this art also in a big festival in Lyon city. It's a light festival, so he will be also presenting his art in this big festival. We have also done some smart shopping related experiments. The city shops, they can create dynamically some offers, like some coupons or some offers of the day, and they can upload this to the city's open data platform, and then our application can recommend to an end user, based on their profile's interest, recommendations about roads to take from point A to point B. So this is how it looks like, the experimentation portal. So the experimenters can register, can access to the platform, and they can start to gather data and build their experiments, manage the life cycle of their experiments, etc. So this is the other EU Korea project that I mentioned, in which we are also working with 1M2M standard as well as the fireware community, in which we are trying to handle this heterogeneity between different platforms. So, for example, from the ski point of view, we are collecting data coming from all of these devices by sensiNact, and then we provide with some standard APIs coming from 1M2M in particular, so that the 1M2M systems can access to that data by using their own APIs. Some particular use cases within this case is indeed, for example, finding friends and family with this. Let me show this. So we have this kind of tags that it will be attached to the, either to the accessories of the people, and this will be attached to the ski shoes of the skiers, that provides various information about localization, etc. And this will be accessed by the sensiNact platform, and will be provided to the ski resort operators. We have also some crowd detectors, in which based on the connectivity of Wi-Fi and Bluetooth, we can detect some crowded areas without any additional infrastructure deployment, just these devices, so that it can get data from the mobile phones of the skiers to detect their presence. So the second use case, as I mentioned, the measuring the ski performance. So we will be deploying this during the Winter Olympic Games, in order to compare the skills of the Korean and French skiers during the period of the Winter Olympic Games. So we will not, unfortunately, have the opportunity to do this with professional skiers, but maybe it can be a next phase. So we have already identified also some other use cases, and we have a kind of a video illustrating the benefit of having this kind of platforms for also smart ski domain. So we have this other project in which we have also access to Santander, Aarhus, and London data. So this was an interesting project in which we also funded some of small companies that use the platform to get data and make some experiments by using our platform. This is, as I mentioned, the Vineyard project, in which we don't have only, within this large project with 70 partners, there are different domains from the farming domain. So we are particularly focusing on the wine domain, but the requirements, what we have observed is that the requirements in different domains as well, they are quite related and similar, so that the platforms can be applied in different cases. Yeah, this one is also presented. So in summary, we are providing this sensiNact platform, which is adopting a device as a service approach, in which it facilitates this plug and play requirements from the IoT domain in particular. We have this flexibility of adding, removing, updating devices with a minimum impact on the running platform. We have this modular development and deployment, which allows us making enhanced system maintenance and evolution. We have a well-established model which also facilitates to build some dependable applications, so that we can verify that the application that we are building will respect to certain properties in terms of security, in terms of concurrent access to some resources, etc. We have sensiNact can be deployed in devices, gateways, also in the cloud environment. So it provides us to the possibility of distributing the processing among different levels in this three-level architecture. And we are simple but extensible data and service model, in which allows the developers to understand the model and the APIs, and also providing this tool that allows them to quickly build some applications. So what we are doing is, with all this ecosystem that we have, all the partners, now we are creating a global alliance to define the cities of tomorrow. So what we have observed is that we need a kind of sustainable forum, sustainable place, beyond these projects that are funded from different funding agencies, that we need to share this with the community and also invite new components, tools, hardware or network infrastructures from different partners, in order to provide a global one-stop showcase of a set of integrated open smart city solutions. So this will be a testbed-oriented initiative in which we will promote open solutions for the cities in particular. We want that those both demand and supply side come together, and they better exchange. The cities provide their real requirements so that the solution providers can better understand them, and also provide some guidance to those cities and showcase what they have and validate them in close to operational environments, even operational environments, so that the cities will join this and they will open us a physical testbed infrastructure, experimentation space, and the other partners will build teams. The software component provider, as I mentioned, hardware, network, the startups that they have some innovative ideas, and they will realize these testbeds and pilot deployments in order to further have some business opportunities or some research partnership between the researchers and the industrial partners. So we would like to provide this direct contact between the city authorities and solution developers, and in particular build this common language so that this can be comprehensible by each stakeholder. So one of the problems that currently we have in the cities is that they are aware of the potential of IoT, ICT, but they are quite lost because there are many initiatives, many activities, and research institutions like CA, for example, okay, so they have a kind of important role to play, because the cities, they really count on the institutions like us to guide them for their digital transformation. So in many cases, they count on us more than they would to large companies. So for this, we have a quite important role to play. Yeah, so this is the structure of the alliance, in which we will have some specific groups working on the technical aspects, building, proposing reference architectures, and planning the integrations between different partners in order to build and organize those test beds that will be deployed in those cities. We would like also to take into account the social aspect, so non-technical issues like ethics, privacy, personal data management, design, art aspects, and for sure business task group, which will allow to build some win-win business models among the participants. We have already established different links, so we have already confirmed interest from several cities in Europe, Japan, and Korea in particular, also in Taiwan. So we have strong links with these different large consortium, IoT Acceleration Consortium in Japan, for example. There are like more than 2,000 industrial and public institutions member of this, as well as Global City Teams Challenge also is an initiative launched by NIST, in which we have strong links, and also in particular we are a strong active member of IoT European Platforms Initiative, in which I am personally coordinating the International Collaboration Task Force, with which we have different links to different other countries worldwide. So if you are interested, you are for sure welcome to join to this initiative. That's all from my side. So if you have any question, I can try to answer. Thank you.